like I said, a very easy day compared to what we were doing last week. I thought it would be nice to kind of take a break and do something that rational expressions with like bases. So what it means to be a base is the denominator. That's all that is. So this 6 right here is a denominator in this example. Okay, when I say a base, that's what that is. It's a denominator. So in this situation, the whole entire day is going to be the same base. We don't have to find the least common denominator. We'll do that tomorrow. We'll take it slow today. So then that's our first step, just to make sure that they're the same. Second step is we're going to combine the numerators. Remember, combining just means add or subtract. What I saw in my last period class was that people were multiplying, and that's not the operation. The operation here is adding and subtracting. Okay, and then we're going to keep the denominator. When you add fractions, if I have 1/2 plus 1/2, I have now 2 halves, which make a whole. Okay, so make sure when you're adding fractions, you're keeping the denominator the same. Very common for people to add those. Someone say something? Okay. And then we're going to factor if we can. So let's look at this example here. What's my base? What's my common denominator? 6. So we're going to leave 6 alone. We're going to keep it down there. But we're going to add the tops. Oop, that's supposed to be a highlighter. We're going to add the tops. So what's 7 plus 3? 10. Now can I simplify that just one step further? Yeah. How? Yeah, everyone was saying 2. And you're correct. So I can technically reduce this by 2, which is dividing by 2. What does that become? When I divide the top by 2, what do I get? 5. When I divide this by 2, I get 3. Okay, that's just normal fractions. I have 7/6, then I have 3/6. I now have 5/3 after you reduce it. So now let's do some more practice with it. Again, all going to be like bases today, so it should be pretty straightforward. I do have common denominators here. I'm going to add the numerators. What do I get when I just add them?
3x².
Careful. 4x. Yeah, so I heard a couple people say 3x squared, and I would be 100% okay with that if we were multiplying. But I have 1 of something and 3 more of something. I now have 4 of something. Okay, so we're not multiplying, but very common mistake, so don't feel bad. Now we're almost done. We just got one more step. How can I reduce 4/8? Divide it by 2, and what's left? You could divide by 2, you could divide by 4 too. Which one do you want to do? The 4. 4 is more likely to get us a smaller answer. Here's a trick for you, and I like to show people this just because I want you to think of math as something that you can manipulate and come back to. So I can manipulate this. Think, what's 8? Look at the bottom first. Divided by 4. That's probably easy, right? What's 8 divided by 4? 2. And is it going to go on the top or bottom? The bottom. You're right. Because, again, you're reducing by 4. You're dividing the top and bottom by 4, and that still gives you the same answer. Okay, so I like to manipulate the problem sometimes. I say 8 divided by 4 is 2, and it has to be on the bottom. Okay, I want you to try this next one. Same thing. It's very simple, very straightforward today. I'm not trying to, I thought we needed an easy day compared to last week. Yeah. What's 6 divided by 3? Yeah, you got it. You're doing a great job. Pretty straightforward. When you're done and when you're done only, look up and see if you got it right. If not, maybe you can find where you got it wrong. Give me another second to make sure that you're trying it still. Questions on that one? Okay, cool. So we're flying by already. Now I want you to change this to cubed. That was my bad. I was typing these notes at 2 in the morning last night, so my brain was not seeing that little 3. It was supposed to be a 3, and I put a 2 on accident. So this one, though, we are subtracting instead of adding. But I want you to get in the habit of changing the sign in the middle. When you subtract something, complicated right now, but it's actually easier to add. So what I'm going to do is I'm going to change it to positive, but then change all the signs after it. That's what happens when you have to subtract. Now, the reason why I'm doing that is because tomorrow more it's going to be difficult because we have to distribute the negative. But here it really didn't matter, but we're still going to do it just to get in the habit of it. So what is 7x squared minus x squared? Yeah, 6x squared. All over 4x cubed, but we can reduce it. What can I divide the top and bottom by to reduce this? Yeah, 2, which then becomes what? Yeah, we're just going to do the numbers first. So I have 3 on the top and 2 on the bottom. You're correct. Now, I have 2 x's on top and 3 on bottom. How many's left and where is it at? I have 2 on top, 3 on bottom. I cross 2 out. How many's left and where is it? 1. Where is it at? Bottom. Very good. Okay. Try the next one. I do 1, you do 1. I'm going to make this a squared here. Again, a typo on my part. Make this a squared so you can do the problem. It's supposed to mirror exactly the one above it. Because it's 7 minus 1.
Oh, because everybody rolled on top?
Yeah, so whenever we have minus, we're going to change it to plus and make this minus. So you want to change it to adding and change all the signs after it. So really you're doing...
every roll minus 1?
Yep. Give it a minute here. When you're done and when you're done only, look up and see how you did. And always check my error. I've been making a lot of errors today. It's like a Monday and my brain is like not awake. 'Cause I was up for, I think I slept for 2 hours last night. So if I make a mistake, please let me know. I need you guys to just as much as you need me. So again, you're subtracting. This cancels. I have 2 on top, 1 on bottom, 1 goes away. Back page when you're ready to go so I know we can move on. And they're pretty straightforward. There's really, you're just adding the top and then you're simplifying. Tomorrow might be a little bit more challenging when we don't have same bases, but we'll take that on tomorrow when we get there. Okay. All right. Same problem. I see a minus in the middle. So that means I must change this to adding and change all the signs that come after it. Now I only have 1 here, so it's pretty straightforward, but again, in the future, we're not going to always have that. So it's nice to get in the habit of it. All I'm doing is I'm adding or subtracting, in this case, the numerators. What do I get when I heard this was a B here, right? Or is that just mine? You guys have a B here, correct? Mm-hmm. Okay, I don't know why I didn't transfer over. What is 7 minus 3? 4. AB? Again, you're just rewriting the bottom. It's a common denominator, so 10a squared b. Now, that's the answer, but you can start simplifying things that we're used to doing. Let's start with the numbers first. Is there a number that goes into both 4 and 10?
2.
Yeah, 2. So I'm just going to divide both of them by 2. What's on top? What number?
2.
Divide by 2, which is 2, and then 10 divided by 2? Very good. Now, I have 1a on top and 2 on bottom. How many's left and where is it at?
1 at the bottom.
Very good. The b's are gone. You're done. Try the next one. Okay. Actually, no, we're doing the next one. That was my bad. we're gonna go over that now. We're gonna do the next one together, and then you'll do the following one. Sorry. Okay, this one, same situation, but we have adding in the middle, which is great, so I don't have to change any signs. However, I now have a variable and a number on the top. I don't just have like what we've been doing. So I must add the x's together. What is x plus x? That's if I multiply them. 2x. There we go. Good. What's wrong?
It's crazy.
What's crazy?
I don't know. It was a joke.
Okay, so then on these next ones I have a number and a number. So all I'm doing is I'm adding them. I'm not multiplying. What's 9 plus 7? Yeah. All still over my common denominator of 10. Okay? So all you're doing the same thing, but you're just adding like terms. You're combining, you're adding like terms. X plus x is 2x. 9 plus 7 is 16. You're just combining what you can. I can't combine x and 1 or x and 9 because they're not the same. I have apples and bananas. They're different categories. Now, we can simplify this further. What number, here's a trick. I didn't show this in my last class, but is there a number that goes into all three of these? 2. Just simplify all of them by 2. So here we go. What does this become when I divide it by 2? 1. Or just x. What does this become when I divide it by 2? 8. What does this become when I divide it by 2? 5. And you're done. Try the next one, please. Same type of problem. I do one, you do one. Add the variables, add the numbers on the top. Combine like terms. More than welcome to work with each other and ask questions. Yeah, so this one, we have to first change, this is kind of what I was talking about up here with the negative. You have to change the sign to addition and distribute it to both of them in order to do this. So you'd be doing 2x minus x, negative 5 plus 7. So we'll go over that. Okay, you guys are doing really good with this, but keep going. Some of you are still working. Give me another 30 seconds here. You guys are going to leave with all your homework done today? 'Cause it's going to be that fast. Okay. What number goes into all three of them? Because it has to go into 3, not just one of them. It has to be all of them. Yeah, 2. So I divide all of these by 2 is what I'm doing here. So I have x what? All over
3. Oh, I know.
2. Very good. Okay. Now, that's the biggest thing though. If I had, again, just pretend with me, don't even write this down. And if I had this, you couldn't do it. It has to go into all 3 of them. It can't, if 5's here, you couldn't have divided by 2. Because it's not all 3 of them. Okay? All right. This one. Very similar. Just one more extra step. And we already talked about it a little bit. I told you to kind of get in this habit. Whenever you see a minus sign, you must change it to plus. But then change all of the signs that come after it. So I'm going to change this one to negative and this one to positive. Okay, that's what happens when you subtract a binomial. Technically, you're distributing a -1 to both of them. It's a -1. You're distributing it in. But now we should be okay. We're back to what we just did. So I have 2x minus x. What do I get? X. And then I have -5 plus 7. 2. All over 2. Done. There's nothing else I can do. Now, so many people, I'm not even joking, do this, and it's very understandable. They're like, oh, cool, x. You can't do that. You have to leave it alone because it's going x divided by 2 and 2 divided by 2. It applies to both of them. So be careful with that. I see it all the time. Okay, try the next one, please. Same thing. me know if you have any questions. Here's this one. I mix up all of the mark caps. Okay, hopefully this is what you got. Or at least close to it. Remember, you distributed that negative, and there was nothing else I could do here, so I can move on. Give you a second to make sure that's all written down correctly. 2 more, and we're going to call it a day. Alrighty. Here we go. Make sure everyone's got that down. Okay, so this one. Don't let it trick you. I promise you it'll work out. Now, again, when you see this negative in the middle, you have to change it and distribute. I know that there's only one here, but I'm telling you, a lot of people forget there's a negative there. So you might as well just get in the habit of whenever you see a negative to distribute it. Now, I technically can't add those together. One's an x squared and one's a 4. One's a number, one's a letter. I can't add them. They have to be exactly the same. So I just rewrite it. Didn't do anything besides combine them. Well, I can't combine them, but I put them next to each other. Same common denominator. However, there is something that we can do, and I know that you guys were all really good at, especially I know Katie's really excited to do it. You liked these ones. Difference of 2 squares. What's the square root of x squared? Yeah, what's the square root of 4? And then how do I write that when I factor? There we go. And from there, we can see that this lovely piece cancels, and I am just left with x minus 2. I really need you to get better at factoring. I know it's hard. I'm not saying it's easy by any means. I just really don't want you to struggle next year if you're going to Math 098 and not know how to factor. So at least when we do factoring, try to really catch on to it. Because, and if you get stuck, I'm here every Thursday. Softball starts today for me, but every Thursday I'm here. Okay? So come and see me. I do want you to do the next one, and when you're done, raise your hand. I will give you your homework.
Me too.
Good. Amazing. So much better. You got so much better than my other ones. Awesome. Okay, so it's pretty fast. The first 2 on here are review of factoring. I'm going to keep throwing them at you. It's the MA table. I'm going to keep throwing them at you because I want you to keep practicing with them. I keep throwing them at you. I'm going to keep throwing them at the MA tables 1 and 2. That's review. Got it? Yeah. Good. Good. Yeah, something is wrong. Look at this. What's happening?
Want me to unplug it?
Yeah, it's the best. Get it! Geniuses you all are. Again, the very first one I'm going to do with you because I want to make sure that you truly get factoring. I don't know what's wrong. I actually have a new sharpener. It's at home. I'm going to bring it. I really want to do the first one with you just to keep reminding you on how to do these factoring. It's not going to go away. Genius. Awesome. Okay. I want to do number 1 with you just because I want to, again, one more time, make sure that you're getting factoring. I promise you it's not going away next year. So I keep putting these 2 review problems on here. I'm going to probably do it the rest of the year because that's how important factoring is. Until you really start to get it, I'm going to put it on every single homework assignment. So, number 1, I want to do with you just to make sure that we totally get it, or at least somewhat are getting better at it. It's always what multiplies to that C value, the A times C, which is just 12. Because it's 1 times 12. It's 12. But then adds to the middle term, adds to 7. Now, some of you might know it right away, and that's totally fine. That's awesome. That you might not even have to make the table. Perfect. But some of us might need to go through it, especially when they're harder numbers. Go in order. Remember, I always told you back in the day, don't play the multiplying game, play the dividing game. 12 divided by 1 is 12. That's never going to get me 7. Go away. Let's try 2. What's 12 divided by 2? 6. Is that going to get me 7? No. Okay, let's try 3. What's 12 divided by 3? Is that going to add to 7? Yeah. Okay, that's my magic numbers is what I used to call them. So that's when we would write that out as x plus 3 and x plus 4. That's how you factor it. Because now if you were to distribute, remember I used to tell you the claw, looks like the Krusty Krab claw. If you were to do that, you're going to get back to that answer. They're reverses of each other. They're inverses. One's a factored form and one's a more distributed out form. They're opposites. Okay, I just wanted to help you out with that first one. Now maybe you can do the second one. Got lots of time.